Okay, with these problems, we look at linear inequalities. And in many ways, the algebraic algorithms work the same for both inequalities and equalities. But here, what I think you'll notice is that um, when you multiply or divide by a negative value, you switch the direction of the sign. So I'll show you what I mean. Here we have negative 4x plus 2 is greater than 10. Well, first I might subtract 2 from both sides, and this is just as I normally would do, um, in most balanced equations. So anyway, subtract 2 from both sides, and now we get negative 4x is greater than 8. To solve it, we divide both sides by negative 4, but that's where things get a little bit different. Now what's going to happen is instead of x being greater than 2, negative 2, we have x is less than negative 2. And the idea is that, and here you can have a little graph of the line. Here's x is negative 2, less than negative 2. So here, for an answer, you pick negative 4 because that's in the solution set. Negative 2 is not, it's going to be less than that. But why switch this direction of the sign? For me, the easiest way to think about this is with a different example. If I said 3 is greater than 2, and then I multiply both sides by a negative 1, or multiply everything by a negative something, I would get negative 1 times 3 is negative 3, 2 times negative 1 is negative 2. But now what's true? Well, now negative 2 is greater than negative 3. So in effect, essentially what we have here is 3 and 2. Here's 1, 0, negative 1, negative 2, negative 3. If we start off with 3 being greater than 2, well, that's true, but when we multiply both by a negative value, they get put on the opposite side of the number line, right? So 2 gets placed here to negative 2, and 3 gets placed to negative 3. So essentially what happens there is that the greater absolute value, which is what the greater number is with the positive numbers, becomes the lesser number when you switch the sign because the greater absolute value for negative 3 is it's further from 0, which means it's more negative or has a smaller value. And the same is true if I reverse it. If I went from negative 3 up to positive 3, or if I went from this inequality up to this one, by switching the number sign, I also switch the direction as well. So think about how value and absolute value are related to each other, and that's kind of what's happening there when you multiply or divide by a negative. Which ordered pairs in the solution set the following system of inequalities? Well, here I think the graphing calculator is something that is really valuable. Although with this particular case, these are fairly easy to graph by hand, I want to use a graphing calculator so we get a sense of how this works. So here on the graphing calculator, we're going to enter these functions by pressing y equals. So y equals, for y1, it's going to be 0.5x. Now there is an x button on here if you haven't noticed. But here you'll see a bunch of symbols, xt, theta, n. But that's the x. So 0.5x plus 4. But this is y equals 0.5x plus 4. And you can see it here on the graph, right? But we don't want that. We want y is less than that. So when y is equal to 1/2 x plus 4, that makes the line. But when it's less than 1/2 x plus 4, it's everything shaded below the line. So here, if we scroll to the left on our graphing calculator, to this region over here, we can change it from a line to whatever we want. So if you hit enter, right, you get different options here. Here, see this triangle here shading above. We want to shade below, right? That's the option right there. And now when we graph, you can see it shades below the line. So essentially, remember that the line itself is the balance between y and 1/2 x plus 4. If y is less than that, it's this entire region below the line. Now we do the same thing for the next graph, except it's greater than or equal to. Now I don't think that the graphing calculator can distinguish between greater than, just greater than, and greater than or equal to. But let's just scroll through the options because I can't remember exactly if it does above, below, and then no, it does not. Okay, so here, let me just go to the above function this time. So the upper region is now shaded. So y is greater than or equal to negative x, so negative x plus 1. Enter, and we graph. So here you can see that, right, the solution for both inequalities is the area where the shaded region is darkest. That's because it's where both lines have a shaded region. So here on the graphing calculator, you can scroll to see the points that are in this region. But I think you could see that, for example, 3, -5, right? If we go to 3, oops, 3 about here, and then -5, we go below the first line, but below the shaded region. So it doesn't work. And that just means that if we were to plug it into this first equation here, if we were to plug 3 in, right? We'll plug this one first. That's 3 is x. It's 1/2 times 3 plus 4. 1/2 times 3 is 0.5 plus 4 equals 4.5. Now, is 4.5 greater than y? Yes, if y is -5. All right, that's true. What about the next equation? Is -3, because it's negative x, plus 1 less than or equal to -5? Well, -3 plus 1 is -2, which is greater than -5, so it doesn't fit in both inequalities. So you could test the points out, I'm just saying, by plugging them into both and seeing if it's true. Is the x value, when you plug it in, does it create an expression that fits the inequality in relation to the other variable? And this one does not. And if we go through it, right, 4, 0 is a great candidate. You can see it right here. And they usually try to make it pretty friendly to find the point. 4 and 0 is in your shaded region, so that's the answer. But let's see what that looks like, even without graphing, how we can plug that in. In the first inequality, y is less than 1/2 x plus 4. So if we plug in 4 for x, we get 1/2 4 plus 4. And for y, we get 0. Is this true? Is the right side greater than the left side? So 1/2 4 is 2 plus 4 is 6, and that's greater than 0. So far, this point checks out. If we plug it into the other inequality, the same thing should happen. It should also be true. So we plug 4 in, we get 1/2 times 4 plus 4. Is that greater than 0? And again, it is. We have 2 plus 4, which equals 6, and that's greater than 0. So this is the only point out of these 4 that when you plug them into both, you get 2 true statements, and that's how you know it's a solution. But also you can see on the graphing calculator is that darker shaded region. Okay. Peter begins his kindergarten year able to spell 10 words. So he starts at 10. As soon as I hear start, I think, okay, that's going to be the y-intercept. He's going to learn to spell 2 new words every day. So 2 new words per day. Write an inequality that can be used to determine how many days it takes Peter to be able to spell at least 75 words. So that's 10 plus 2d. When is it greater than or equal to 75? Right? Subtract 10 from both sides. Okay. We get 2d is greater than or equal to 65 divided by 2, and d is greater than or equal to 32.5. So if you're counting whole days, it's the 33rd day and beyond. Use this inequality to determine the minimum number of whole days it will, so here they say it. What's the minimum number of whole days? Well, it's everything greater than or equal to 32.5. So the first whole day where this happened is 33, right? We round up there. What is the value of x in this solution? So my usual instinct is to distribute first. So I'll solve this in 2 ways. I'll use my usual instinct, and then I'll solve it a different way. So less than 4. I distributed the -2, so -2x times -5 is plus 10, less than 4. Subtract 10, and what do we get? This cancels out. 4 minus 10 is -6, greater than -2x. Divide both sides by -2, and x is greater than 6. Greater than 3, right? Because when you divide by a negative, you reverse the direction of the sign. Another way to solve it, just to see if this makes more sense, and we should get the same answer. So same thing, except because 4 and 2, because 2 is a common factor of 4, I know I can divide everything by -2. And in this first expression, this cancels out. And over here, 4 divided by 2 is just -2. So here we divided both sides by negative sign, so we flip this direction. And we get x minus 5 is greater than -2. We add 5 to both sides, and we get x is greater than 3, the same thing as before. So they want us to pick an x value that fits. They usually give 3 as kind of like the trick choice. Don't pick that. It's got to be greater than 3. So here the choice is choice 4, which is 5. Okay, Tamara has a cell phone plan that charges 7 cents per minute So 7 cents times the number of minutes plus a monthly fee of $19. Her budget is $29.50 per month, and that just means that she can't spend more than that unless she wants to go into debt. What is the maximum number of minutes she can use? So how many minutes can you use plus the 19 and always stay less than or equal to $29.50? That's the goal here. We subtract 19 from both sides, right? What do we get? 0.07 m is less than or equal to 10.50. So I divide both sides by 0.07, and we get what? Well, m is going to be less than or equal to, this one I don't feel like doing in my head, but 10.50, if you have a great way to do this in your head, let me know, divided by 0.07, that's 150. Okay. So that means the minutes has to be less than or equal to 150 minutes. And so that means you could use 150 or anything less. Okay. Okay, so you want to graph these two linear inequalities. And I would actually resist using the graphing calculator here because x is greater than 2. That just, for me, I mean, that's a little bit trickier than graphing y equals, to mess around with the graphing calculator. But also, this is so easy to draw by hand because if we rewrite this first equation, instead of 2x minus y greater than or equal to 6, if we rewrite that into y equals mx plus b format, we can quickly change the way this looks in terms of complexity. At least that's how I love to graph in mx plus b format. So I'm going to add y to both sides, so I get 2x greater than or equal to 6 plus y. So I just added y to the left, that cancels out the negative y, and I balance that by adding to the right. And then I subtract 6 back to the other side. Cancels out, I get 2x minus 6 is greater than or equal to y. So here, this just means that my y-intercept, right, is negative 6, and my slope is 2. So I can quickly set up my y-axis, right, and my x-axis here, and then just mark off these two things where the y-intercept is negative 6, so 1, 2, 3, 4, 5, 6. It's here, and the slope is going up by 2 each time, and this line is telling me that y is less than or equal to, right, this line right here. We draw the line, so y is less than it. It's this shaded region here, lower than the line, right, shading the whole thing. Typically we see a bunch of lines right there. Okay. Then the other line is x is greater than 2. So x is equal to 2 would be a vertical line where every point is the point where x equals 2. This vertical line right here. But it's not the vertical line because they're saying it's greater than 2, so it's just a dashed line, right? And that means it could be greater than this line but not equal to it. And you just shade in the region to the right. And they want us to graph these two and state any coordinate in the solution set. I'll pick one that's kind of definitely in the solution set. That's where the two regions cross. That's 1, 2, 3, 4, down 2. This is 4, negative 2. Sorry if the graph is a little bit sloppy, but it's just a tool that's working for me on this grid. So you have 4, negative 2 is a point that's in both regions. All right, hope this helped. Okay, here we have a sign. It tells us at a county fairground. And h represents the height of the rider. In inches, what is the correct translation of this statement? So the rider must be at least 48 inches tall. So the height has to be greater than 48 inches, but it could be equal to 48 inches, which is choice 4. Less than or equal to 48 would be at most. Less than would be, well, I think they would say less than 48 inches, and more than 48 would be more than. What is the value of x here? Well, we have 4 thirds, and I want to get rid of the thirds. It seems to make my life easier. So to get rid of thirds, we multiply by 3. So if I multiply everything by 3, I can get rid of this fraction. 3 times 4 divided by 3 is just 4, right? 3 divided by 3 is 1. So it's 4x plus 5 times 3, 15, less than, well, 3 times 20 is 60, and then we subtract 3 groups of 3, which is 51, or we can think it's 3 times 10 plus 3 times 7, which is 30 plus 21, or 51. We subtract 15 from both sides. 51 minus 15, that's 36, is greater than 4x. Divide both sides by 4. X is less than 9. So here, don't pick 9. X is to be less than 9. So x could be 8. All right, next. What graph represents the solution for 3y minus 9 less than or equal to 6x? So I'm going to utilize the graphing calculator here, but I'm just going to rewrite this in y equals mx plus b format. All I have to do is add 9 to both sides. That's my first step. This cancels out. 3y is less than or equal to 6x plus 9. And I want to know what y is, so I divide everything by 3. And what that will do is I get y is less than or equal to 2x plus 3. Right? Because 6 divided by 3 is 2, and 9 divided by 3 is 3. So here we have, notice that y is less than or equal to. That means the line has to be solid. These dashed options, the options right here, the line's dashed, that's for less than or greater than. So here are the two choices. I have to pick one because y is all the values that are less than the line. So it's all these values here. If y were greater than all the x values, it would be this region, greater than or equal to. It would be this region here. And again, the dotted line just means greater than or less than, but not equal to. Okay, what is the solution here? Well, I'm going to rewrite this and then distribute my 3 to 2m minus 1 because I could divide everything by 3, but this 4 and 7 over there, 3 is not a factor of 4 or 7. So you get these nasty fractions. I want to avoid that. So 3 times 2m is 6m, minus 1 times 3 is minus 3, less than or equal to, it's still 4m plus 7. I want my m's on the left-hand side, so subtract 4m. Both sides, okay, it cancels out. We have 2m minus 3 less than or equal to 7. Get my numbers to the right and add 3. So you get 2m less than or equal to 10. Almost done. If 2m is less than or equal to 10, divide everything by 2, and m itself is less than or equal to 5. So here, I'm going to pick choice 1. M is less than or equal to 5. All right. On the set of axes below, graph the following system. So it's interesting that these systems are typically pretty easy to draw by hand, so it's good practice for us. Here they're giving us the equations in y equals mx plus b form, and notice that our y-intercepts are both positive, positive 1 and positive 4. That might make our life nice and easy here, I hope. So let's graph this first one in red, right? Y is less than 2x plus 1, so plus 1. That means our y-intercept's there. 2x, well, 2 is the slope, up 2 over 1, right? So these points right here, I know that I only need 2 of these points, but it's not just really hard to graph these by hand. With a tablet, so I want to be as accurate as possible. Okay, I think that's pretty good. Okay, so that's for y is less than 2x plus 1, but let me just, oops, I'll put a dashed line in there. Because it's less than 2x plus 1, right, that just means that you can't include the line itself. Sorry, so this is not easy to draw these dashed lines by hand for me. Okay, so everything less than or equal to this line. So it's this whole region here, right, and we'll color code. Color coding is surprisingly helpful in these kind of problems. Okay, so next, we use purple. Y is greater than or equal to negative 1/3 x plus 4. So now it starts up at 1, 2, 3, 4 here, right? And it's negative 1/3 x, so that means down 1 over 3, right? So down 1, 1, 2, 3. Do it again to be accurate, and again. All right. So now we can just draw the line through these points. Pretty accurate. Nope. Okay. Then it's a little bit better. All right. So they're just saying here that y is greater than or equal to this. So it can be anything up here. And the solutions, right, for this system is all in this region here where the two lines intersect. So you can pick any point there and you're okay. So let's pick 1, 2, 3, 4, 5. 1, 2, 3, 4. So you can pick any point you want, but if we go up 1, 2, 3, 4, 5, then up 4, 1, 2, 3, 4, 5, we'll go both. Here, this point, 5, 5, is in both. And if you're not really sure, you can grab something like a calculator, which I'll show you. But But also you can plug 5 into both of these and the inequalities will be correct. If we plug in the first one, we get 2 times 5 plus 1, and that's 11, which is greater than the y value of this point, 5. So that's okay. The second one you can also plug in x for 5, negative 1/3 times 5 is negative 5/3, plus 4, so that's 12/3. Altogether, that would be 7/3. Is that greater than or equal to less than or equal to 5, right? The y value at this point. Yes, 7/3 is about 2 1/3. It's 2 1/3, excuse me, which is less than or equal to 5. So it does check out in both. So this point you can plug it into both equations. Here, so clear this off. When you enter this in, first y is less than 2x plus 1, so 2x plus 1. I already have it shaded, but I'll show you how I got that. If you go all the way to the left here, you want to pick the graph that's shaded below because in this case, y is less than, right, the line itself. So they have the upper region shaded and the lower region. You pick the lower region. Here in the next one, I'll pick the upper region because y is greater than or equal to. Although I don't think this calculator can distinguish between greater than or equal to. Next we have negative 1/3, which I'll enter as a fraction, negative 1 divided by 3, x, and then plus 4, enter, and graph. Right, so this will graph both for you, and if you find x equals 5, you can scroll over if you want. So about here, and then up 5, you can see that it is clearly in the region for both. Alright, let's keep going. Roger's having a picnic for 78 guests. He plans to serve each guest at least 1 hot dog. If one package P contains 8 hot dogs, which inequality could be used to determine how many packages of hot dogs Roger will need to buy? So there's 78 guests, and they have to each have at least 1 hot dog. So you have to have at least, right, greater than or equal to 78 hot dogs. And each package has 8 hot dogs. So it's 8 times the number of packages, right? If we had 1 package, it would be 8 times 1, or 8 hot dogs. If we had 2 packages, it would be 8 times 2, or 16 hot dogs. So you have this set up, you divide both sides by 8, and P has to be greater than or equal to, right? Set this up here, second quit. 78 divided by 8, divided by 8, 9.75. So P has to be greater than or equal to 9.75, right? Here, they didn't want to know the answer. They want to know what was the inequality we could use to solve it. I didn't recognize it. Excuse me, but there it is, choice number 2. Alright, which order pair, is in the solution set? Well, we can graph both, or we can plug these points in to find out. It's really up to you what you want to do, but I think I'll use a calculator. It's just so much faster. So first we have a less than and then a greater than or equal to, which is pretty standard, and I have these set already to it. To set them to less than or greater than or whatever, excuse me, you scroll to the left for whatever function you're on, all the way to the left, and hit enter until you get a region above or below. You see this little triangle pop up above a line. That means greater than, and then if it's lower than the lower triangle, it means less than. So fortunately, that's what we have here. We have 2x plus 2, right? And y is less than it, so it's the region below the line. And the next one, here we have negative x minus 1. Okay, then the graphing calculator will graph both for us. Apologize. Oh, I didn't type it correctly. So it's negative x, clear it off. Sorry, negative x minus 1. Okay. Now, if we graph both, what's going to happen is the graphing calculator will show you the shaded region. And you can kind of see here that 2, 0 is the point that's actually in both. And if you're not entirely convinced, plug 2 as the x value and plug 0 as the y value into each inequality, and you'll see it's the only point that really works for both. Okay, then wants to graph this inequality and then tell if the point 1, negative 3 is in this inequality. Let's first find the point, see if it's in there. And it's actually quite easy to do. What you could do is plug the x and y value into your inequality. So we have 4x minus 3y. So 4 times x, or 1, because they give you 1 in this point, minus 3 times y, y is negative 3, is that greater than 9? Well, 4 minus 3 times negative 3, that's plus 9, is that greater than 9? Well, yes, it is. 13 is greater than 9. So there you could say, well, therefore the point is in the inequality, and we'll see that in the graph in a moment. Next, for me, what I like to do when I graph is rewrite in y equals mx plus b format. So that means I want y all by itself. I add 3y to both sides. I just do that to get rid of the negative 3y, right? I'll turn it to a positive. 9 plus 3y is less than 4x. And then I want to start isolating y to get it in the right format for me. These cancel out. 4x minus 9 equals 3y. But I don't want to deal with 3y. I want to know what y is. I divide everything by 3. And what that will do is it will set it up so it's 4 divided by 3 right over here. 4/3 x minus 3, because 9 divided by 3 is 3, equals y. And this is the equation for my line. Now what's nice about this, what I like, is that it gives you the y-intercept and the slope. That's why I like this format. So the y-intercept is this number, negative 3. So negative 1, negative 2, negative 3, it's this point right here. Slope is 4/3, so up 4, 1, 2, 3, 4, over 3, 1, 2, 3. And y, or equals, y is less than, not less than or equal to, just less than. So we dot our line here, right, as an approximation. You'll have a ruler, and we shade in everything below it because y is less than it. And you can see that 1, negative 3 would be right here, which is in the solution set of the inequality. So just to reiterate, you can find out a point is in an inequality by plugging it in. You can also graph the inequality, shade the appropriate region, and see if the point actually goes there. Okay, so this is a problem that I think is a good one because it's pretty complex, and it's a good example to practice as you get ready for questions like this. So they tell us that ninth graders need to purchase a park permit for $250. So to access the park and use it for whatever, they have to pay $250. But you know, you can tell this is going. They clearly want to make that money back. So the ninth graders who attend, they get 75 cents per plate. So for ninth graders, it's 0.75 per person X. Guests, however, are different. If the guests will probably pay more, right? Guests will pay $1.25 per guest, right? All right, G for guest. So if 200 ninth graders attend, which inequality can be used to determine the number of guests needed to cover the cost of the permit? So they use, instead of G for guests, they use X. So it's 1.25 times X. Okay, so notice that all these, the left-hand side is greater than or equal to 250. That means that the amount of money you make should be greater than the cost of the permit, which was 250. So here, I would actually use either choice 3 or 4 because we're looking to see now how many ninth graders need to attend. We're not looking for 0.75x. That would tell us how many ninth graders are attending. In fact, we're told how many ninth graders are attending, which is 200. So both choices here, they take 200 and multiply by 0.75 because they want to know how much money they've already made and how much is left, right? So here, you're going to add 1.25x because that's saying, well, we have 0.75, that's 75 cents, times 200, the number of ninth graders. How much more will we get, right, per guest, so that the total is greater than or equal to 250? If you find x here, you'll find how many guests you'll need. So that's choice 4. All right, hope this helped.